We're continuing our lesson on functions and describing what we can see from a graph. So in this first graph, we just want to read some of the inputs and outputs that exist in the function. For the first part, we have f of 0. F of 0 means that the x value is 0. So if I read when x is 0, the output is also 0. That's why we have a point here at 0, 0. So f of 0 equals 0. F of negative 2 means when x is negative 2, we're asking what y is. What is the output? So when x is negative 2, the output is positive 1. F of 2 would be when x is positive 2, what's the output? So the output would be negative 2. X-intercepts are looking at when the graph crosses the x-axis. This graph is crossing the x-axis three times. It happens here at 0, 0. So that's one of the x-intercepts. It happens again at 4, 0 and at 6, 0. So there are 3 x-intercepts. The y-intercept is when the graph crosses our y-axis. So here the graph crosses at 0, 0. Okay, there's a question up here on the right that says, is f of 1 positive or negative? So it's not asking you to find f of 1 like we were finding here on the left, but just to describe what's going on in the graph. So if I look for when x is positive 1, it would be between 0 and 2, and I would see that the output is negative. I might have to estimate what I think that output is, but for us, this question is just asking if it's positive or negative, and the graph would definitely be negative. All right, notice the difference here in the next question. It says, if f of x is equal to 3, then x is equal to something. So it's really asking when the output is 3, what x value makes the function equal to 3. So I'm going to look across the graph. Here, the output is positive 2 when x is negative 4, and we start to decrease, and then it starts to increase again. The function does eventually reach positive 3, and that happens when x is 5. The next one, if f of x equals 0, then x is equal to something. So it's asking when is the function equal to 0? Well, the function reaches 0 here when x is 0. But it happens again. It's going to go down and back up, so it reaches 0 again when x is positive 4. And then again when x is positive 6. So it happens 3 times when x is 0, 4, and 6. In this next question, it says f of x is less than 0 on the interval blank. So we're wondering, when is the function less than 0? When are the outputs of this function less than 0? Well, the output started positive here at positive 2, then went down to 1, eventually went down to 0, and we have a negative section between 0 and 4. Now we're describing the x values of the function, and those x's are between 0 and 4. All of the outputs for those x's will be less than 0. So I'm going to include or put 0 to 4 here. And notice I didn't put brackets. I used parentheses. That is because the question, in this case, does not ask when it's equal to 0, only when it's less than 0. At x equals 4, we are equal to 0, and when x is equal to 0, the function is equal to 0. So then the next question does include when the function is equal to 0. We're looking at when it's greater than or equal to 0. Well, the function starts out greater than 0. So there is a section that is greater than or equal to 0 from negative 4 all the way to 0. And notice I did include the brackets on this one. It is definitely above 0 when x is -4, but it is also equal to 0 when x is 0. That's not the only section, though, that it is greater than or equal to 0. We have the second section here from +4 to 6. So we would do union bracket 4, comma 6 with a bracket. Both of these sections would show when the function is greater than or equal to 0. And then lastly, we're asked about the domain and range. The domain is the set of x values for the function. So we're reading from left to right all of the x's that exist in the function. Well, this function exists when x is -4, so -4 has an output. If we kept reading, -3 would also have an output. In fact, every x between -4 and -3 has an output. We can keep going. From -3 to -2, all of these x's have outputs as well. So the graph exists for every x from -4 all the way to when x is 6. We would write that domain as bracket -4, comma 6 with a bracket. All right, and then we look at the range. The range is the set of y values in a function. So if we describe all of the y values that exist somewhere in the function, we start with our lowest y value. This lowest y value is -2. And if I kept looking, let's say, does the function ever reach -1? Yes, it will. It reaches -1 at this x value and again over here at that x value. It doesn't matter that it happens more than once. All we care about is that y value represented somewhere in the function? So from -2 all the way to +3 would be the range. We write that as bracket -2, comma +3 with a bracket. All right, the next graph, I gave you a little bit more of a funky graph on purpose. And so we're asked about the domain and range here. What you can't really tell automatically is that this function starts to get vertical. All right, so if I look from -4 to the left, we can see this function was going up on the left here, and it gets vertical. We can kind of see something called an asymptote. We are going to deal with asymptotes quite a lot in this course, especially as we look at rational functions. So this vertical asymptote is preventing the graph from having an output at -6. And it's what's making the graph get vertical as we get closer to -6. That value would not be represented in the domain because -6 does not have an output. Now, if I went to -5.5, it does have an output. If I went even to -5.9, it's eventually going to have an output. -5.99999 would have an output. So I can get very close to -6, but -6 does not have an output. So in that case, I'm going to put a parenthesis, -6. And then describe even more x values that exist in the function. Well, every x beyond -6 until I get to -4 has an output. So we would say from -6 to -4 with a bracket. There is a gap in the x values. We see that none of the x's between -4 and -3 have outputs. If I look across the graph, there is a big gap in this disconnected graph here. So we need a union symbol that's going to represent that gap and say it starts back up at -3. Since that -3 has an open circle, we would not include that in the domain. But then from -3 on, every x value has an output. So from -3 to +infinity. As we list the range of the function, we're describing the y values that exist. So here the y values start at -5. We always go from least to greatest. So from -5 up would be the range. From -5 to infinity. Now, sometimes people ask about that gap here on the left. Well, if I look across the whole graph, every y value, even -3, -2, -1, exists somewhere in the function. If I was trying to find when the function reaches -2, it happens over here on the right side at when x is +6. So the graph does reach these y values in between -3 and -1. It just happens here on the right section of the graph. The graph, when I'm describing the range, does not care about if it's connected or disconnected. All it cares about is what set of y values exist somewhere in the function. All right, so let's go to these questions on the right side. F of -1 means when x is -1, the output is down here in the negative section, and we don't have an exact point, but we can zoom in on that graph and kind of estimate where we think it is. This would be somewhere close to -4, but we haven't reached -4 yet. It's maybe -3.8. You might have to estimate every now and then, and that's okay. So -3.8 is the output. When x is +3, the output is -5. All right, for question 5, if f of x is equal to -1. So this case, the question is asking when is the function equal to -1? If I look across the graph, this equals -1 more than once. It happens when x is -4 and when x is 7. So you're going to list both of them. So -4, comma, and 7. Or you could write that out as x equals -4 and x equals 7. All right. For question 6, the function is equal to -4 when x is equal to 0. But it is not the only time this graph ever reaches -4. So it hits -4 again at +4. So the function is equal to -4 when x is 0 and when x is 4. All right, if we describe when the function's less than 0, I'm going to highlight those sections first. But we have a less than 0 here on the left side. It's a small section, but it is between -5 and -4. Notice for -5, I did not put a bracket because at -5, it's equal to 0, and the inequality does not include when the function's equal to 0. I did put a bracket on the -4 because the output for -4 is definitely less than 0. There's a gap in this though, so I'm going to need to do a union symbol and show what the other section would be. This would be from -3, so parentheses -3, all the way to 8. Now that 8 is not included either, because when x is 8, the output, the function is equal to 0, and our inequality, again, does not include when it's equal to 0. Then we're asked about our x-intercepts and our y-intercepts. So our x-intercepts are where the graph crosses our x-axis. That happens here at -5 and at +8. So we have two x-intercepts. One of them is -5, 0, and the other one is at 8, 0. The y-intercept is where the graph crosses the y-axis. That's over here at -4, but the actual coordinate is 0, -4. All right, there are 2 more graphs here for you to try on your own in the last page. So if you want to pause the video, try these, and then we'll come back together and you can press play to check your answers. All right, so if you've already done these, I'm just going to go through the answers to these. The domain for this graph would be from negative infinity up until negative 3, union negative 3 to positive 4 with a bracket. Notice that negative 3 does not have an output at all in the function. So it has to be broken and excluded from the domain. Now negative 1 does have an output, so there's no need to exclude or break the domain at negative 1 because every value around negative 1 has an output. The graph doesn't have to be connected for me to describe the domain. All right, the range of this function would go from negative infinity all the way up to positive 3 with a bracket. And then there is a union. Now, when I look at this y-axis from 3 to 4, there is no y value. Across the whole graph, you'll see that 3.5, 3.1, 3.9 never exists in the function, but positive 4 does. So since positive 4 is just a singular value that exists in the range, we put it in these little squiggly brackets. We call them braces. And that's what happens. That's what we'll use when there's a single value. F of negative 4 would be 0. F of 10 does not exist. That function does not continue on past positive 4. So x equals 10 is not in the domain of the function. Therefore, its output doesn't exist. F of x is equal to negative 4 when x is negative 6. So it's asking when the function reaches negative 4, and that's when x is negative 6. The inequality, the function is greater than negative 1. So I'm going to highlight all the sections where it's greater than negative 1. Here is one section, and it's from negative 5 to negative 3. At negative 5, we're equal to negative 1, so I'm not including that. And at negative 3, there wasn't an output anyway, but we're not including when it would have equaled negative 1 as well. So that open circle would have automatically made that a parentheses, even if that had said equal to negative 1. But there is another section, so I'm going to do union. This is still greater than negative 1 for all of these values. And that would be from negative 3 to positive 4. We're describing the x's, so that's when x is negative 3 all the way to when x is positive 4. And actually, that positive 4 would be a bracket because its output is absolutely greater than negative 1. Its output is positive 4. As we describe the x-intercepts, in this case, there's one x-intercept. It's at negative 4, 0. The y-intercept would be at 0, positive 4. For your last graph, as you describe the domain and range of this one, this domain would go from negative infinity up to 0, union 0 to positive infinity. The only x value that does not have an output would be when x is 0. If I look for these other open circles, like when x is 2, there is an open circle, but there's also a closed circle. That closed circle shows that x equals 2 does have an output. It's at positive 4. Same thing happens when x is negative 1. The range for this function would go from negative infinity all the way up to positive 4 with a bracket. Actually, that is wrong. So I overlooked a section. There is a whole gap here in the function's range. That gap, so the negative infinity all the way up to negative 1 would be one section with parentheses, union, and then parentheses 0 all the way to positive 4. This section here from 0 to 4 does have output or are outputs somewhere in the graph. Now x or y equals 0 is not in the range because it doesn't have an output of 0 ever. All right, number 3 are the x values for which f of x is equal to 3. This is equal to 3 for a lot of x values. It's for this entire section of negative infinity all the way to -1 with a parenthesis. It is equal to -1, never actually. So there is no x value that exists that would give an output of -1. All right. Number 5 says f of -1, the output for when x is -1 is +1. The output for when x is 2 would be +4. We're looking at the defined point. The function is greater than 0. So I'm going to describe that whole section. That would be this constant section's all above 0, and then that little section there on the left. So that section would be from -infinity up to 0 with a parenthesis. It is still greater than 0 from x equals 0 to x equals 2. So I'm going to do union parentheses 0 to 2 with a bracket. All right, and then it asked, when is the function less than or equal to negative or +1? So just kind of ignore the fact that I'm having to double color some of this graph since I can't erase it. But there is a section that is less than or equal to +1 from -1 to 0 with a parenthesis, union 0 to +1 with a bracket. And we have another section here that's less than +1. So that would be from 2 to infinity. All right, so there's a lot of information that we can gather from a graph. Here's a little bit more practice on that. And if you have any questions, please send me a message.